Electrical wires can be either joined or terminated safely in several different ways. One way of doing it is by crimping on a piece of hardware, an example of which is here in my hand. And this crimping means that this hardware gets placed on the bare end of the wire, just like so. And in this position, this round part on the hardware gets permanently deformed with an appropriately sized and shaped hand tool. I'm going to show you close-ups. And this permanent deformation here on the round part of the hardware produces a friction fit union of the two components, the wire and this bit of hardware. This friction fit joining of these two pieces must be solid, so if it's wobbly or loose any which way, it's not good enough. Because if there is any gap between the two of them inside this barrel part of the piece of hardware, then there's going to be arcing and sparking inside. Electrical arcs are very hot, able to melt metal, and that's exactly how electrical fires get started in some cases. Either which way, electrical fires is what we don't want. So, these crimped-on connections are very popular in automotive use, in all kinds of appliances, minor and major, in power tools and shop tools, and inside a range of electronics. In all of these applications, the common theme is being able to connect and reconnect repeatedly, like plug in and disconnect repeatedly, typically plugging into a motor or a circuit board or some such thing, and being able to withstand motion and vibration this way as well. So, in this video I'll show you a number of design variations of these crimped-on connections. We'll discuss technical considerations, tools needed, and skills necessary. Let's get started, or let's continue with this type of connector, which is the female part of a male and female connection. So this female socket end looks like this, and the male counterpart would be a blade that has the same width, and it slides into this female connector part. So it's a blade and this socket together. It's a bladed connection. Male and female parts, obviously made for joining either two wire ends together or terminating a piece of wire, and the male end would be part of a motor or a circuit board, and it plugs onto a circuit board. When this is crimped on, this is how the finished product looks like. The design of the female connector is somewhat similar. The similarities, I think, are obvious, and you can see how this is how the finished crimping product looks like. So the round part on the connector, or this piece of hardware, gets not just flattened, that's not good enough for electrical connection. It has to be rolled inwards into this shotgun barrel shape, and that's what's crimping and hugging the electrical wire right around here, thereabouts. So this was the bare end of the wire. From here you can see this insulated or this insulation on the wire, and this piece of hardware here on this is the barrel end. On the barrel end it has an extra two tabs here that wrap around and grab the insulated portion of the wire. This used to be round. Here is a design variant that's closer to this one. So originally they start out like this, round, and as they get deformed with the crimping pliers, they get this shotgun barrel shape, because the jaws on the pliers form this. So if these connectors, if the barrel ends just get flattened with a pair of pliers, that's not good enough, that's not solid enough. So take a look at this crimping tool, very straightforward. You can immediately see how the crimping is produced by different, whatever part of the jaw fits there. And that brings us to this side of the tool, wire gauge sizes. Gauge 26, gauge 22, whatever gauge, 14 to 18. This is about gauge between 14 and 18 is 16. So if I place it in here, you can kind of see, oops, let's see, yeah, this way. You can see how this was produced with the tool thereabouts. Okay, sorry about that. This makes sense, I hope. And the ends were crimped with another tool. Okay, so this tool is very inexpensive. It's like $10 to $15, and this connection is, like I said, it must be solid, and indeed it is. So if you pull on it, there's no looseness. There shouldn't be any in any kind of direction. These connectors are widely available in electrical suppliers' catalogs. Let me just switch the page or turn the page. Here are some examples. Some of them you can see there's the male counterpart, which is just a flat blade. That's the female counterpart. So this one slides into this socket shape. Some female variants are fully insulated, some others are partially insulated, only the barrel end is insulated. Some others are bare, like this one or this one. And you can see 90-degree variants similar to this one that we started with. You get the idea. There are also different shapes on it, and I have examples of these on the table here. Sometimes wires are terminated in a ring, terminal ring on a or a terminal fork. These are also crimped on. They are widely available just like so. Typically the barrel is insulated only because the uninsulated part is getting bolted down or screwed down to the frame of a trailer for signal lights, or to the appliance's metal body or some such thing for ground cables typically. So all of this is widely available in electronics part suppliers. So that's just some ideas, and of course the tools themselves. Let me just turn the page back to the tools, so more shapes of all kinds here. The tools themselves are also available, so none of this is rocket science. Sometimes you can get a kit with a bunch of stuff in it and appropriate tools with it. So let me put you back down here for a sec. So this is the two types, terminating a wire into a fork or a ring shaped connectors, and with these male and female connectors, like I said, they come by the hundreds, or I don't know, okay, this is maybe 50. They are also part of sometimes a bigger socket. So take a look at this shape here. This is from, I don't know, from an appliance, and you can see inside how this crimped-on connector is placed inside this white nylon connector. So the hardware is inside, the female connectors are there, and it plugs onto something. Or it could be part of the wiring harness in other configurations. You can get it in single variants, and you can see through the plastic enough to recognize the shape inside as is. So that's what's inside. There you can see it's crimped on, and it's really solid. There is a little bit of movement here of the whole piece inside the connector there, but it's fine, that's normal. Here is another variation in design. This is instead of a flat blade and a socket, such as for these ones, this is more like pins into cylindrical sockets, like so. And this connector or body, this black plastic, is molded, injection molded, so the wires and these connectors inside are all inside, and this molten plastic is injected around it, and so that's how this is part of a trailer or some such thing. So that's how this looks like. If this needs to be repaired, it has to be cut off. from the whole harness and replaced as is. These ones, you might be able to take it apart if it's defective and pull the wire out from it. It's very finicky. You need to get in with a needle to release the metal fitting inside. Here is a hybrid version which doesn't have these bladed connectors. Where are they? These ones, which doesn't have the bladed connectors inside, but has a variant of these pins inside. But they are also crimped on. You can clearly see the same crimping idea there. And so that's how the barrel connector female ends look like. If you look down the barrel ends, you can see the wires there, the wire ends. So made the same way, and they can release out of this connector with a lot of misery with a pin. It's difficult, but it's possible. One other crimping variant that I want to show you is this. It looks like a wire nut, but it's not. A standard wire nut looks like this and has a threaded coil. Yeah, just a coil inside. It's not threaded, it's just a coil inside. And if you join wires together just by twisting two wires together, such as the case here, this can work well if it's not subject to vibration, and just twist it on and it's fine. But if you want to crimp them together, there's a crimping variant, this one here in my hand, and it's the wrong size. It's too small, so it doesn't really slide on, but this is the version and it gets crimped. You can see this crimping can also be done like quite brutally, like so. So not all crimping looks the same. This one is crimped this way, but it's the same way. You get the idea. There's a bare end of a wire and it's crimped on real solid. Okay, so that's how these look like, and that's the tool that's needed for it. These are some design variations. One last thing, very important though, wire sizes. This here is a wire stripper. Obviously all of this wiring project needs to get started with a piece of wire that is there. Here's a wire end that's insulated. So what you need, you have options here. You can use your teeth to bite this PVC off the wire. Do not recommend that. You can chip your teeth really easily and effectively with this. You can cut it with a knife and peel it off, or like this way, whittle it away. Don't recommend that. You're going to cut into the conductor eventually. It needs a proper tool such as this. Now the wires have a gauge number, which were also indicated on this one, gauge 22, gauge 18, whatever. And if I pick a spot here, this one is a good spot, you can see AWG, there, AWG 16. I know 16 is there and AWG is there, so this is 16 wire gauge, American wire gauge. That's its size. It's like a shoe size, just this is wire gauge size. So what you do, of course, you need a fitting with a barrel end that's made for 16 gauge wire, which this is. I don't know if the packaging says so. No, it says 25 pieces. Okay, not 50. How about this one? It doesn't say what gauge it is, and it's very old. But what I want to point out is this is a wire stripper. This insulation needs to be removed. So your teeth, not recommended. Knife, not recommended. You can see when it works like a scissors, and it's kind of sharp there at the edges there. And as it cuts, it's got a hole through there, so 16 wire gauge is there, and it's not gonna cut into the conductor inside. It only will cut into the insulation. So I'll show you how it looks like when it works flawlessly. Cut into it one way, rotate 90 degrees, make sure it's the same. Maybe a second cut is not always necessary, such as the case, but I only cut off a little bit of the insulated end, so you get the idea. This tool provides a cut that does not cut into any of the individual wires in the wire strand. I'll show you what happens if you use the wrong size. Typically, okay, if you use one that's way too big, it's just not going to cut anything. If you use one that's way too small, or even just one size too small, you'll see it's going to cut through a few of the copper wires. So rotate 90 degrees, and if I'm lucky, yeah, I got one piece here that fell off there. That one fell off the bundle here. So you get the idea. And I have a second one here. So two pieces of wires were cut into, and that means that you made the cross section. There goes another one. You saw it fall. So it's still somewhere on my fingers. Yeah. So you get the idea. These wires. So you made the wires cross section there a choke point. Not a good idea. It needs to be full thickness along its entire length. So strongly recommend that you get another $15 tool like this. And this is, I don't know, what's the manufacturer? No, Vice Grip is the manufacturer. That's how it looks like. Very straightforward item, and you can make proper electrical connections with this. With these two tools. Yeah, it's not sticking to my finger anymore, but you get the idea. So wire sizes and the wire stripper need to match. The barrel end sizes on these connectors need to match to the size of the wire, and the slot used on the jaw of this crimper tool, of course, needs to match to everything. Other than that, it's very straightforward, just needs a little bit of practice on some spare wire. And of course, once this is deformed, it's really not fixable, so get yourself a bag and take some time and practice some of these. It's not rocket science. You can work your way around these evil connectors, and it's fairly inexpensive. Thank you very much for watching.